So welcome to 2016 question A-4. This question is kind of orthographic projection and auxiliaries and a bit of problem solving with a cube and drawing a sphere around it. So the image below shows the structure that is in Brussels. Okay, it's based on an inclined cube. The drawing on the right shows incomplete projections of a similar cube. Complete the elevation of the cube. So we've got our plan, we've got our auxiliary elevation, and we have our elevation. So the heights here between my elevation, auxiliary elevation and my elevation will be the same. It's just a matter of, I suppose, making sure that we draw everything correctly and have the hidden detail lines in the correct positions. So what I'm going to do first of all is I'm going to project up all these edges that I'm going to need. Okay. But you approach this whatever way you feel will suit yourself. Okay, and then I'm actually going to also project back. Yeah, that's at 45 degrees, which is brilliant. I'm just going to project down here just to show heights. It'll be easier for me to measure off, and it also allows me to identify edges in common, so I can see, you know, this edge, this vertex is representing here and here. Okay, so that's just something to deal with. I'm going to first of all deal with this surface in here. Even though it's hidden detail, those are the edges of it in elevation. So I just need to find one more point, okay, and that is the height of that point. So it's been projected up, and I'm going to get this height, and there that is. Okay, so that should allow me then to join here to here, actually a heavy line. Okay, so that is one surface. Okay, next I'm going to draw the surface connected to that, so with a shared line here. So this surface here, even though it's a hidden detail line, like it's kind of, we're looking from above it obviously, we have got 2 points of it already, so we just need to find these final 2 points. So if we look at this point, it's joining to the bottom. The height of that point is going to be here, so I can get the height step it off there, and then this point here, project it up, the height of that is there, so I can get that height. Okay, so 2 more points, and that will allow me to join them up. So from the bottom to that point, which is here's the corresponding. Okay, and then that joins up to the point that I just found, so that joins to there, and then that will join back to the final vertex of that side. Okay, so that's the bottom part there. I suppose we're going to draw the top half here. We've got most of it, so I'm just looking for that final vertex, which will be here, right at the center. So I'm going to extend that vertically up. Okay, and that, you can see here, that's the height for it. So find that height and step it off. So I can draw in that face of the cube as well. Okay, so that's the projections of my cube. Now, there's also hidden detail here, so we need to remember that part of it. Okay, so where are we looking now? We want to find that back corner, okay, which is from here. Okay, so that back corner, it's that height, so get that height again. Okay, alternatively, it's at the same level there, so I could have just projected those across, but look, it's done now. That's right, make sure it's on the right one. So here, and that will all be hidden detail running to that point. Okay, so that is completed elevation of my cube. Right. Finally, then they want us to draw a plane and elevation of the smallest possible sphere that would contain the cube. So, if you imagine here we have a cube. Okay, I'll just show a little bit of hidden detail. So, what we want is a cube that has a diameter that will run from front here to the back here. This came up in a question on another year. Okay, so from the front top corner to the opposite back bottom corner, that would be the diameter of a cube or a cylinder that would contain that whole thing. So we need to find somewhere where we have a true length for that. Okay, and where we have it is it's actually in a couple of positions. Actually, maybe only one position. Yeah, one position. So if I'm looking in here, I want to imagine this line is running from one top front corner to one opposite corner. So that's the diameter. Okay, so if I get the radius of that then, okay, I can get that radius, and that would be the position of that circle, or that sphere. Okay, it would also be here. Okay, so even though it appears that it's not touching off of those vertices, it actually is. Okay, it's just that it's obviously a curved object. Okay, and then to locate that in elevation, we can just get that height, step it off, and that should actually intersect my vertices. Yeah. Okay, another method would be if you joined opposite diagonals, so front here to the bottom there, and from the top there to the top there. Yeah, that's on the exact same point. Okay, so that is our center O. Let's label that center O, and center O. Okay, so that is the 2016 question A4.